So now we're going to show you how to secure your system in 60 seconds. Hopefully it'll actually happen in 60 seconds. Your mileage may vary, but we're going to install ToolVault. We're going to onboard every agent and MCP server in use on the machine. We're going to convert all the tool usage to managed and containerized. And that's very simple. We're literally just going to type npm install -g ToolVault to install ToolVault globally. We're going to run it, and then we're going to click a couple buttons. So we'll show you the demo of that. And this is kind of what the import screen is going to look like. So let's start with the installation. This will take various amounts of time depending on the state of your NPM cache, but generally 30 to 60 seconds is safe. So we're doing a fresh installation. And as I said, this is about 20 to 30 seconds. Okay, so now we've installed it. So we've installed it, and we now have two applications installed. One's called TSH, which is our ToolVault shim. That's the small standard IO MCP bridge that each of the agents will now run instead of running tools directly. And we have the ToolVault application itself. So we're going to run ToolVault on port 3000. The first time you run it, it's going to take a little while because it's going to have to build some containers and start some containers. So we have some generic NPX and UVX runner containers that are how we containerize some of the services. And we also have proxy containers to support NPM and Python package proxying to make those containers run fast. They're small ephemeral containers that get started and stopped a lot. So it's important that they start quickly, and we have some technology to help make that happen. Okay, so now we can see we're ready on localhost 3000. So let's open link. And now we're looking at the product. So when you first come in, it's pretty simple. There's not a lot to see. But let's just go through the kind of the speed run of the demo if you're going to onboard for the first time. And I will say, if you go into the help, you'll see the quick start guide, and that actually takes you through the exact steps that we're going to do now with links to the pages that we're going to do them on. But we're just going to go through quickly and do this. So let's say discover clients. We're going to do a global scan for system or application level tools, and we're going to do a project scan, but we're only going to look for projects currently using tools. And I'll show you an example later on in the demo of why you might want to use projects that are capable of using tools but aren't using tools yet, so that we can bring them in and deploy tools to them. But for now, we're just going to stick with this. This is a highly optimized heuristic to be able to scan an entire hard drive. That was about a 200 gig hard drive with quite a bit of data on it, but we have, as I said, a pretty highly optimized process that can scan that in a few seconds. So we've found that we've discovered a bunch of clients. So we're going to import all but one of them. We're going to leave, we're going to leave this one off and import the rest of them. So when we import the clients, we're going to set them to auto update, meaning we'll be able to synchronize to them later. We're going to convert all the found servers to managed servers. So we're going to take the MCP configurations they have in those clients, and we're going to replace them with links to our gateway. And pull those servers into the gateway to be managed. And we're also going to run the servers in containers that are capable of being run in containers for added security. So let's hit import. We're done. So that's it. All of these clients are now running securely, and all of the servers they were using before are running in containers. So let's go through and look at a couple things. So we can see the clients that got imported. Let's go into one. So this is one of the clients. We can see the servers that it has. So it was using memory, file system, and fetch. They're all synchronized. We can see that they're managed. We can see they're all being run in containers. So these are all considered secure. And then let's drill into one of these. So let's go look at the fetch MCP server. So that'll take us to the server details. And we can show the clients that are using it. So we can actually see, okay, that fetch server that got imported, there were actually two clients that were using the fetch server with the same exact configuration. So they're now using the same managed fetch server. And let's go look at Claude. Probably should have shown this before so you could see the before and after. The servers start up a little bit more slowly the very first time that they're started than they do in subsequent times, somewhere in the range of 5 to 10 seconds. So we have this time server that's connected, and we can see now it used to just be a UVX server that ran standard IO MCP server directly, and now it's actually running TSH, which is our shim, and it's passing these configuration parameters. And So let's see if we can get it to use the tool by asking it what time it is in our time zone. And it's using the tool. Okay, and we can see that we got the time at 1:58 p.m. PDT, which is correct. And let's go back into our servers and we look at the time server. We do a bunch of things, so we can see what tools it has available. We can test those tools here. We can see the logs from the container that's when it started up, or from the server when it started up. We can see which clients are using it, and we can also see the messages that came through it. So here in this case, we can see that Cloud Code Global, which is what we were running, it was in a project, but the MCP server was installed globally. It initialized, it listed the tools, and it called the get current time tool, and we can see that it returned the correct time in local time. So we can actually see that we can verify that Cloud Code is now using this time server through ToolVault. So let's go back and look at another kind of client import. So now we're going to import this VS Code project, TeamSpark AI, API. This time we're not going to convert the servers to be managed. So we're just going to leave the servers in place, but we're going to bring the client or agent into ToolVault. So we can see that we brought one in, and this is it. So if I go here, I can see that it has one server, which is Git, and that server is unmanaged, which means it's still running the server directly. It's still just calling this via UVX and running it with these parameters. So one thing you might have noticed is this compliance thing lit up when I did that. So when I imported the server. So we go into the compliance guidelines. First of all, there's a pretty big explainer. If you pop this down, that explains how we determine compliance and what your compliance goals and objectives ought to be in terms of tool usage. So we want to have both of our security settings turned on. And then we want to have managed client configuration. So we want all clients to be managed and we want all of their servers to be secure. So this kind of goes through the different levels of compliance events that you can have and the best practices. So we'll close that down for now. So what we can see is that we don't have any system issues because both of our clients' system compliance settings are turned on, and then all of our clients are compliant except for this one that we just imported because it has unmanaged servers. So you can see that you have a compliance issue because it has unmanaged servers. So let's go see if we can take care of that. So let's go back to the servers. So we can see that it's unmanaged. So we can do what we call a convert, which will convert this to a managed server. We're not going to run it in a container. I'll explain why in a second. So let's convert this to a managed server. So now it's a managed server and it's been converted. But you still notice that I have a compliance issue over here. So if I go back here and see what's the problem now, it has non-secure servers. So the server is managed, but it's not secure. Okay, let's go back and look at that. Now the problem we have here is that this server is in a class of servers that when containerized don't run properly because this Git MCP server just runs Git on your local machine. So it requires the ability to run a command directly on the host, which is not a particularly secure thing to do. And if we converted this into a containerized server, it would fail. So we're not going to do that. But at least now we know via this compliance function that we have a server that's not running a container that is potentially dangerous. So let's go talk about how we would install a new server and how we deploy servers to clients. So this is basically the import process. It's pretty simple and painless if you just sort of click all import, convert, like you're going to be running all your clients with secure tools through ToolVault. But let's say we wanted to install a new tool. So we have a server catalog, and I'll talk just a second about kind of where that came from. We looked at a bunch of options for public registries of MCP servers and didn't really find any that we felt like were the right kind of blend of security and legitimacy and but still had a large scope. There's a lot of like very small bespoke registries that have a few, a couple dozen servers in them. There's a lot of giant registries that have thousands and thousands of servers. They're almost all very scary and very bad and vibe coded. So we wanted to find some middle ground. So we really liked the Model Context Protocol servers page registry. This is just a markdown file that's maintained by the open source community. But we felt like this was actually a pretty good mix of the sort of official servers, the third-party servers that are semi-official, that are generally made by the people that you would expect them to be made by, and then a bunch of community ones that are all pretty decent. So this is about 1,000 servers. So this isn't really machine consumable. We wanted to show this in our product. So we built a thing called the TeamSpark MCP server catalog, which is open source and available to anybody to use in their own products that they want. So on a daily basis, we have an automated process that goes to this model context protocol servers page and processes it, converts it, visits all the GitHub repos for all the servers that are listed there, collects a bunch of information, and basically builds a big JSON file that like I said, anybody is free to use to put into their own product. So this is essentially how we built our directory from that directory. And then what we see is when we go into our product, if you go to server catalog, you're going to see that same exact set of servers in that same interface. So it's kind of nice, if you can click down and say, I just want to see the official servers. And if you want to search, I want to see official servers that have something to do with SQL. So now I'm down to like 7 matching servers. So it's pretty nice. You can use tags and text to search to find the server that you want. And let's go try a couple of, let's try this agent QL just as an example. So we can see what it looks like. We can see what a sample configuration looks like. We have information about the repository, where the source code is, how many stars, last updated, and tags, and then a description. So if we were going to go install this, we would hit add server, and this is our installation interface. So when you install from the catalog, it maintains a link back to the catalog so that anytime you go look at that server, if you want to go back to the catalog to see more information about it, if you're trying to debug it or figure out what the parameters were, or just want to find the source code, you can easily get back to the catalog from the installed server. So pretty simple. I'm not actually going to install this, but I just wanted to show one thing, which is that when we pass parameters in the configuration that look like secrets, we have a way to detect whether they're secrets, and if they are, we obscure them in this way. So we basically have an ability to show and hide things that look like secrets. And if you were to install that and look at the details, they would also be hidden in the details, and you'd have to hit a reveal button to show them. So we try to be careful about not accidentally showing anything that might be a secret on the screen. And let's go try a different one. So I'm going to try an example that I know is going to fail just to demonstrate it. So Auth0, that's the product that we use and we like. We know a bunch of people who work there. So we can see the server configuration, the repo, all the stuff. And I'm like, this is sort of interesting, because you would think, having used this product, you're going to need a lot more context than that to use the MCP server, but whatever, it doesn't look like it takes any other context. So let's just go add it, save it, and let's go try to use it. And it's going to fail. And you're like, that's interesting. I wonder why it failed. So one of the things we have is we have logs. So for every MCP server that you run, you can come in here and look at the logs. It's really a nice way to just manage the tools in general, because you can test the tools. You can look at the logs of the containers. You can see the messages flowing back and forth and audit everything. But if I go to the logs, I can see, it actually does require a bunch of configuration. It requires access to a configuration file on the local machine that we haven't given it access to. So that was just sort of an example of how logs work and how servers fail. So we'll just delete that. And let's go install something that will work a little better. So let's go look for SQLite. So let's add a SQLite server. And I'm going to give it a database. And we're going to run this in a container. Now, one thing that's interesting about this is that obviously we're going to run this in a container, but it also needs access to this file. We automatically detect when we convert something to a container whether any arguments look like file paths, and then we validate that they actually are valid file paths. And if they are, we build container mounts automatically so the containers can access those files. So basically not anything you need to worry about. It is a little bit of magic, but we can support automatically containerizing things that refer to local file paths. So that looks good. So let's save that. And then let's just go see if we can play with this tool a little bit. As I said, the first time you click it, 5 or 6 seconds to start up. Subsequent times it starts in about a second. Let's list tables. And we can see, okay, so we are actually looking at that SQLite database. We were able to list the tables, so we have a tool that works. Awesome. And we can ping it to verify that it's connected, that sort of thing. Also look at the logs, just see that it's started up properly. And let's go now and do sort of the last part of this demo, which is, okay, so I've installed the SQLite from the catalog, and now I want to deploy it to some clients. How do I do that? And there's a couple ways to do that, but let's do it this way. First of all, one of the clients I want to deploy this to doesn't use tools yet. So let's go import that client. So this is where you want to use projects capable of using tools, because it's going to find projects that we know we can deploy tools to that aren't actually using any tools yet. And we filtered those out of the first list because oftentimes you don't want to import those, but sometimes you do. Okay, so we're looking for a specific, this one right here. Let's turn all these off because we're just going to import this one. So this is a VS Code project in the toolshed directory. And we're going to import that. And there aren't any tools being used, so it doesn't really matter. So let's just do that, import the client. Okay, so now let's go back to this SQLite server and say, hey, we want to deploy the SQLite server to a couple of clients that we know use that particular database. So let's go to add client, and we're going to say it's this toolshed and this one, which isn't currently using any tools that we just installed. So these are the two clients that we want to have access to that server. We hit add, we can see they've both been added. So you can see that it did deploy it to Cloud Code. So there it is. There's a SQLite that we just deployed. So it wasn't there before. We deployed it, and now it's there. So it's a pretty easy way to install and manage. You have your set of clients that you've imported, typically automatically. You have a set of servers those clients use, and as you add new servers, you can easily deploy those servers to clients, see the relationship between the two. You can monitor. You can check the messages. If you're taking advantage of our policy system, you'll see alerts generated by the clients and servers. And you have the compliance feature, which basically allows you to understand, okay, once I've imported all these clients, once I've converted all the servers to containerized that can be containerized, now what are my potential security issues? And you're able to kind of easily zoom in and see, okay, this is what it is. So your corrective action there would be to say, hey, okay, I have this server that's not secure. If I wanted the whole system to be secure, what would I have to do? And the answer is you'd have to go find a Git tool that was more secure, that you like better, either one that could be containerized or that was self-contained or that was in a bespoke container, or that was some other way secured in a way that you liked. So that's the gist of the demo. As in the previous demo, I did show the policy system in a lot of detail and how we deal with the security of the messages flowing between the clients and the servers. This was more about how we get those clients and servers in and how we manage them. It's a really great system. It makes it super easy to find and deploy servers and to deploy them to clients and understand the relationship between them. They're all centrally configured. Just a much, much better way to manage tool uses across an entire system. Hopefully that's interesting to you. As I said, this can be installable right now. npm install -g ToolVault and play with it. Check out the GitHub repo and let us know what you think. Thanks.